The FASS schedule planning unit is the source of flight downstream modules of the system. It is intended to be used for creating, modifying, loading, and exporting flight schedules, both in the current season and in future seasons. The schedule is managed in 3 layers: plan, draft, and corporate. Plans are used privately in the schedule planning department of an airline. The contents of a plan are not expected to be flight ready. They contain changes in progress. The draft is the airline's internal shared schedule. It is expected to be largely operation ready and is used for internal collaboration to attain crew and technical operability. Once the draft is approved by the collaborating departments, it may be published to the corporate schedule. The corporate schedule is typically what is released to the public for making bookings. The latter 2 schedule layers, draft and corporate, are the ones recognized by IATA in schedule exchanges. We now proceed to create a new plan. In this case, we are going to create a plan to maintain selected flights in the current season. The plan is empty of flights in the chosen aircraft type, so we are going to copy from a past season and use the flights as a baseline for the new schedule. The copied flights are not assigned to aircraft, so we effect a simple assignment using a standard FIFO-LIFO pattern. We will discuss assignment mechanisms a bit more later. We're going to start by adding a series of Monday return flights from Gimpo to Busan in the afternoon. But before doing that, we're going to set up the entry time mode to UTC so that it matches the display on the chart. The new flight legs are not assigned to an aircraft. For the first Monday, we manually move them onto an aircraft where they connect geographically with adequate ground times. Then we scroll to the next Monday. Besides some other pre-existing unassigned flights, we see our new Gimpo-Busan return legs again. It is clear that there is a repeating pattern into which the new legs fit, so we ask the system to automatically assign the unassigned legs to aircraft. This function leaves the existing patterns in place and just attempts to move unassigned flights into the gaps, whilst preserving connectivity, ground time requirements, and any other aircraft constraints, like equipment requirements. The Flight Schedule Planning Unit provides a variety of algorithms for assigning flights to aircraft. We just saw one that retains the existing patterns and tries to move the unassigned flights into the gaps. The other algorithms pull the existing patterns apart and rebuild them from scratch, which usually provides a more efficient pattern unless many manual interventions have been applied to the existing assignments and need to be retained. Assign All is the old-fashioned classic pattern builder that simply assigns the flights in, first out or last in, first out order. It can actually be shown that this mechanism creates the most efficient legal pattern. However, it has no ability to backtrack and try alternative patterns where some of the constraints are relaxed. That is what the squeeze algorithm does. Finally, the system offers a genetic pattern builder. That mechanism uses a modern optimization technique modeled on population dynamics and evolutionary processes. It is designed for huge combinatorial problems where linear programming performs badly. The genetic algorithm relaxes all the constraints and instead imposes penalties for violations. The penalties are used in the population model to remove patterns that have poor characteristics. It is, however, not a pure steepest descent algorithm. Pure steepest descent algorithms perform very poorly in problems like roster building and tail assignment because they are full of local optimums. Genetic algorithms allow the optimization process to escape the local optimums and look more widely around the whole search space. The reason for providing multiple algorithms is that each one might fit a different fleet or time period better for a given airline. Earlier, we added an individual flight. In addition to editing flights like that, the FSPU also provides a bulk editor that presents flights in a grid and allows bulk updates to sets of flights. The bulk editor starts by requesting that you identify a working set of flights. You can then work on any of the flights directly in the grid, for example, changing dates, times, days of operation, airports, and so on. Alternatively, you can select subsets of the flights using the bulk selection function and by manually tweaking the selection in the grid. With a subset so selected, you can then apply bulk changes to it, like moving the times, changing the airports, aircraft types, and configurations. The bulk editor also provides functionality to export the chosen flight set to an Excel spreadsheet and to import a flight set from a spreadsheet. You can configure the meanings of the columns, but if the spreadsheet is kept to the same format as the output, the standard column mapping works as is. One of the FSPU's most important functions is to ensure that the schedule is flyable. For this reason, it keeps track of all the problems and warnings in the schedule plan as you build it and modify it. Typically, a schedule planner will aim to produce a schedule that has no problems and only a few warnings. In this case, we have 80 curfew violations, which are flagged as problems. Normally, we would alter the schedule to avoid such violations, but for the purposes of demonstration, we are going to ignore them. Thus, satisfied with our plan, we proceed to distribute it to the rest of the airline for other departments, like crew and technical, to review and possibly request alterations. When all departments are satisfied, we expect them to approve the flights in the airline draft. Once they are approved, the FSPU can proceed to publish them. This applies the changes and updates to the airline's official corporate schedule on which passengers will make bookings. This is the schedule that feeds through to the Real-Time Movement Control Unit, FMCU. There are many more functions and subtleties to the FSPU's operation. This, however, is a high-level overview of what it does and how it manages the airline's schedules, from plan through to publication for operation.